So the first one, which is sort of the most common form of remote sensing in the industry today, is photogrammetry. So essentially photogrammetry was developed during World War I, actually, to measure the depth of trenches. So you use stereoscopic vision to measure the depth of the trenches, but the technology's obviously come on a long way since then. And today we're using UAVs to collect images, so high degree of accuracy images, with georeferencing and stitching them together to create 2D and 3D outputs, which are highly visual and accessible to pretty much all stakeholders. We see that drone photogrammetry delivers the sort of best balance between accuracy, safety, and reliability when we're in the field and delivering that to our customers. Some of the benefits are that it's sort of visually accurate to everyone, guaranteed accuracy and resolution when you're operating with automated flight parameters, and it's accessible, transparent, and you can have quality assured data. We see that data can be captured 400 times faster and 6% cheaper than sort of more traditional survey methodologies. And actually today we're seeing a lot more surveyors, like traditional surveyors, moving into using drones as their sort of primary means of data capture, and then using traditional methodologies to sort of fill the gap between what's possible with photogrammetry and what's required in a traditional survey. In terms of how this fits in with active and passive, this format is a passive form of remote sensing, which means that it relies on light being reflected off of an object and taken in by a sensor, i.e. the lens of the camera, to be sort of collected. That light source, typically when you're using photogrammetry for surveying and mapping, is the sun. So you're reliant on sort of like daylight sources and stuff like that, but it also means you can't see into dark areas and shadows, which is one of the sort of drawbacks of this methodology. Here's just an example of what the pilot sees when they're operating the drone. So this is from the SenseFly EB system. And you can see that the flight parameters for photogrammetry are very automated. You fly in nice straight lines, and you can obviously fly at the same height above the ground to get the same ground sampling distance. So you pre-plan all of these, and it sort of follows the terrain and make sure that everything's collected in the right way. I won't go through all of these. This presentation will be available after this, but some of the key benefits of this is fast and cost effective and quick to deploy. You can capture data once and measure multiple times. So that's one of the key benefits of remote sensing in general. You're collecting all of the data available in an area rather than the specific like types of data. So with sort of total station and other methodologies, you're only collecting the data that you physically can get to. Easy to analyze. Obviously, computers can understand it because it's in the computer's language already. Much reduced land access, so you can fly over areas which you may not be able to get access to, and particularly with some of the attendees that we saw saying yes to this in civil engineering, we all know that land access can be difficult, particularly in the planning phase of a project, so pre-construction. So useful for that, and obviously you get zero carbon emissions and much safer. You don't put boots on the ground and in harm's way. Some of the drawbacks: unable to model features that are hidden from view, i.e. in dense vegetation. So the next methodology will come up to that. And then the others there, including sort of sensitive to lighting conditions, and sort of unable to capture features such as rails, curbs, and building features, as it's sort of susceptible to different types there. Here's just an example of a dam up in Scotland. This was captured with the M300 with the P1 payload. So we've got a resolution of about less than a centimetre on this. This is the point cloud image here, where you can see sort of lots of detail, even down in this sort of sluice gate down here, which is really great to see. One of the great benefits of photogrammetry is that it's really quick and easy to deploy. And here's just an example of where we have been using photogrammetry to model a site in East London every month for the past 2 years. And you can see the progression of this site over time. So you can see the sort of viaduct appearing in the middle. And this is really what we call like Google Maps on steroids. We're able to update this at a very regular interval and allow people on site to make decisions very quickly and easily, and have informed decisions to reduce the risk on site there.